what? I'm sharing my screen. New fear unlocked that I didn't share my screen. Okay. So, oh, feels like forever ago, even though it was just kind of like a normal spacing for us, Thursday to Tuesday, but whatever. I hope you had a great long weekend, day off yesterday. Yeah, I was talking to a coworker, and she's like, "Oh, are you just gonna post videos for them so they don't have to come in Tuesday morning after the long weekend?" I was like, "Oh, that would have been nice, probably for all of us." So that's something we could do for next time. We've got a lot of long weekends in term one, so. All right, but it feels like it's been a while. So we started linear functions. We finished chapter 1 last week, and then we kind of took it back to straight lines, right? Because we had seen some kind of bigger functions, but now we're going to focus on linear functions and then kind of graduate through all the functions a little bit slower. And so linear functions, we talked about y equals mx plus b, right? Where the y and the x are just variables, so you just keep them as y and x. And we did some examples. I'll keep this stuff here because it's a lot, I guess. We talked about increasing and decreasing slopes. So if you have a positive or a negative slope, right, that depends on your rate of change, which is your slope. Right? And then we did an example where we had a slope of the value of a car after some amount of time. Let's say days, no, years more likely, right? Because how do we interpret this equation? 13,000 minus 2,000 for every t, right? So for every day or every year, that's why it's funny to think of t in days. Because the value of the car would depreciate by $2,000 per day. Yikes. More likely that it's years, but it doesn't say, so we decided it was years. We introduced the general interpretation of the slope and the intercept. Okay. These are going to be good to have up our sleeves, right? Just kind of commit them to memory, probably. Not because I'm going to ask you to recite it on a test or anything like that, but it is good to kind of have the general interpretation of the slope internalized. So for each unit increase in x, right? So for each additional year, the value of the car is going to see a $2,000 or negative $2,000 increase, which is a $2,000 decrease, right? And we talked about that in y. So the key here is for each unit increase in x, right? Then we're going to see a slope increase in y. And I can see I didn't underline this as forcefully, but it should have been the intercept. The intercept is the value of y when x is 0. Right? And you can develop these, right? Or you can kind of talk yourself into both of these interpretations by just looking at this equation. So the slope for each unit increase in x, right? B is just b. You can let it be 0 if it makes it easier, right? And so then if x goes from 1 to 2, right, then y is going to increase by m times that 1 unit increase. Whereas the intercept, right, if you let x be 0, this m times 0 goes away, then y equals b when x is 0, right? So you can kind of talk yourself into those interpretations. Right? And then I kind of feel like we ended somewhere around here we've talked about the average rate of change in chapter 1, and we saw it in terms of function notation, which is down here. But the average rate of change between two values, right, is going to be the change in output over the change in input. Sometimes we even call that rise over run. Rise over run. Right. Delta y over delta x, right? Delta meaning change, as we know. So the rate of change of a linear function is the slope of this line. Right? And so you'll be able to find the slope. You have a function, f of x at the second point minus f of x at the first point divided by the change in x. So I'll call that the end of our review. That was just kind of going through the notes that we wrote last day. We'll pick up here at this example. We want to find the rate of change between -2, 3 and 4, 0. Okay. Now what we can do, just for kind of doing a little warm-up stretch here, is we can sketch this out. What does this thing look like? X1 is -2, y1 or f of x1 is 3. So let's do that here. X1 is -2 and y1 is 3. X2 is 4 and y2 is 0. So I've got x1 and x2 and its corresponding outputs. Okay. I haven't really put any lines on here, but let's go like this. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. Good enough. X is -2. That's out here. Y is 3, 1, 2, 3. This is not going to be very beautiful, but that's okay. -2, 3. For the second point, if x is 4, y is 0, then this is my second point here at 4, 0. You don't have to draw it out, but it does give us some clues as to what an appropriate answer would be for the slope, right? Looking at these two things. Oh, I should use the ruler, but okay, yeah, I actually will because it's too far. What? Hey, you can't see the ruler.
Nope.
Secret. I really don't like how it hides my tools. I want you to see me fumbling. Yeah, right, because it just shares my screen in the video. But here, look at this. I've got this nifty ruler going on. And you can see my pen choices. Oh, weird. Yours is different. Well, I think it turns it into dark mode. I don't really like dark mode. But when I'm presenting, it turns it, I don't know, whatever. How do I get rid of this? Just, thank you. There. Some clues. We need a negative slope, right? So if you don't find a negative number, something went wrong, right? So that's your first kind of useful bit of information, right? We see the slope should be negative. Right? If it was going up this way, then it would be positive, right? But we're expecting a negative slope. And the rate of change is the slope. Or here, the slope. Yeah. Okay. You can do this as rise over run if you want. I'll use the formula. I'm going to use this equation here, okay, where f of x1 is y1 and f of x2 is y2, of course. So here, this is f of x1, oops, and this is f of x2. M is f of x2 minus f of x1, the change in the output over x2 minus x1. Stacking our equal signs. F of x2 is 0 minus f of x1 was 3. X2 is 4 minus x1 is negative 2. Uh-oh. I need more room. How about even another line? Eek. Sneaky. This is going to be negative 3 divided by 4 plus 2. Negative 3 divided by 6. You can leave it like that. Or in this case, right, it's relatively obvious that you can reduce it. It doesn't matter. It's the same number, right? Even if you reduce it. If you're using your calculator, I don't think you have to change a setting or anything. It just reduces it by magic. So if you try it and you do negative 3 divided by 6, then it should just, and then hit enter, it should just do negative 1/2. And then if you want the decimal version, you hit the SD button, right? And so here, I will just say, or negative 1/2. For me, it doesn't matter. I don't really care about reduced fraction form or anything like that. Negative, right? That's good. And we can kind of talk ourselves into, okay, the rise is shorter than the run. Kind of looks like we've got it figured out. Nice. This distance here is what? 6. This distance here, 3. 3 over 6. But okay. But if we want to do the same thing, now I encourage you to think about what the graph would look like, right? Just to kind of check your work. And we'll do a quick sketch, but again, you don't have to, as long as you keep track of, your projector. Make sure it's working for you. Oh, that's what I was gonna do. What is f of 2 equal to 3 tells us that x1 is 2 and f of x1 is 3. F of 4, what is going on? It always does that though. It's not out for long enough for me to put in a ticket with IT, but it is really annoying. X2 is equal to 4, right? And f of x2 must be 7. Should we try it without sketching it? and then we can sketch it to check. Let's do that. Because I anticipate on the test, then you just do the calculation. But it's nice to be able to check your work. M is f of x2 minus f of x1. Trust that I'm writing x2 minus x1 on the bottom there. Okay. Seven. I'll need to work quick before it goes to sleep again. 7 minus 3 over 4 minus 2. 4 divided by 2, I'm going to go with 2 usually. Just because I didn't give myself enough room. It's a positive slope, right? You want to make sure that that makes sense. So let's see here. Let's do a little sketch just on the side. Just approximate. You don't have to, I guess I don't need the negative axis. But I do need more positive axis. If x is 2, y is 3, x is 4 is my next one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 is my largest value of y. So I need to have at least 7 there. And let's see here. X is 2, y is 3. Rough dot there. If x is 4, y is 7. That looks like a positive slope to me. So that's good. Good enough. And it's increasing faster than it's kind of going across the x-axis, which means that 2 makes sense here. And again, you can check it, right? Rise over run, all you're doing is finding the slope. Okay. Any questions before we do the next one? The number of students grew from 4,000 in 2008 to 43,000 in 2010. If we assume the number of students is growing linearly, meaning in a straight line, right, then find the rate of change. So the rate of change here. Now we've been given points, right? We've been given x is this, y is this, right? Either as a coordinate or as the function output, right? Kind of graduating slowly. Here, it's our job to determine what the x input is and what the y output is, right? And so kind of leveling up here. But if I give it an input of 2008, I get an output of 4,000, right? Whereas if you give it an input of 4,000, you're not necessarily going to get just 2008. And so that's kind of a non-function, right? And so, but 2008 only had one number of students, right? In theory. And so, or at some point in 2008, let's say, there's a fixed number of students, so a fixed output. And so that means that the year is going to be the input, right? And so here, let t be the input. And we'll let s of t, why did I pick s? Number of students, right? You can pick any name you want. Let s of t be the number of students in year t. Right? Give it some t, it returns the number of students. So then, what are we given? We're given that S of 2008, usually what we do with years is we would drop the 2000, it's fine, doesn't matter, and just probably use 8 and 10, but that's okay. Then it's years from 2000, right? But we'll keep it nice and simple here. S of 2008 is 4,000, and S of 2010, wow, yeah, 43,000. Put commas in to separate. Like, X. That's a huge jump. So what am I expecting with this huge jump? I'm expecting a very large slope, right? Because it should be very, very steep. And so, all right, this is how we were given information before. So we can kind of map it back to the information that we had in the previous example. In fact, we can map this back to the coordinates that we had, right? So, or as coordinates, then we have 2008 and 4,000, which I'm not going to try to map out because yikes, what a mess. But 2010 and 43,000. Right? So you can take that information, you can map it back and simplify it as much as you want. Okay. But all we wanted to do really is to find the rate of change, which is the slope, right? And I will use that terminology, right? I'll ask you, find the rate of change, right? And then you have to know that, okay, that means I have to find the slope, right? So f of x2 minus f of x1 divided by x2 minus x1. Hey, didn't give myself enough room. F of x2 is 43,000 minus f of x1 was 4,000. And 2010 minus 2008. Okay, I will do this. Bad. Keep it nice and tight though. 43,000. Although it is impressive when you guys do the math in your head, I cannot do it. And I don't trust myself anyways. I always check with my calculator. 39,000 divided by 2. My slope, 19,500. Right? Does that make sense? We can use the general interpretation of the slope and say, okay, for each unit increase in x, which would mean in this scenario, for each additional year, right, we see 19,500 increase in the number of students. Right, we saw that there was a huge jump, and so this makes sense to me, right? You always want to make sure that your answer makes sense. That sounds stupid, but it's actually valid advice. Can you imagine getting to watch a show in an 8 a.m. class? Yeah. Business. Here we're finding the slope. Okay. Yeah. Yeah. Okay. Ready to level up or what? Fine. Yeah. Ding, ding. Is it the final? No. I was gonna say the final boss. Find the linear equation that passes through 0, 3, and 3, 9. Now, find the linear equation definitely involves finding the slope, right? But it also includes finding the intercept, right? And so this is the whole kit and caboodle. Okay? I want you to kind of think about how you would do it before we do it together. Obviously, I'm going to walk you through it, but I'll tell you that the first step is to find the slope, which you know how to do. But then try to figure out how you would find B. Just.
Got the slope, you can just follow it to the y-axis.
Okay. So distracting.
They gotta wake up.
Yeah. Yeah, just. Yeah, trying to wake them up. So step number 1. Find the slope. Bless you. The slope is still f of x2 minus f of x1 divided by x2 minus x1. This is the version of the slope formula that I'll give you on the formula sheet. We've seen a lot of them, right? Rise over run, blah, blah, blah. But this is the version that I'll give you on the formula sheet. So that's why it's the one that I'm using consistently. Or should I make you memorize it? Nah, too much room for panic. X1, x2, f of x1, f of x2. So I have 9 minus 3 divided by 3 minus 0. 6 divided by 3, gonna lock it in at 2. I think I'm gonna need another page here. Won't need the full page, but remember that was just step 1. You want to make sure, does that make sense? Right here, I've gone a distance of 3 units and then I've gone up 6 units. Looks reasonable to me. It's positive. That checks out, right? And so now we have the slope. Step 2, find the intercept. This is something that we haven't done yet, right? But I'm gonna just grab what the points were, 0, 3, and 3, 9. Given points 0, 3, and 3, 9. Now, there's an obvious choice here, 0, 3. That would make your life a lot easier. In fact, it's given to you, right? But to illustrate what you would do if you weren't given the y-intercept, right? So here, I'll just highlight that this is already the y-intercept, right? I'm kind of cheating a little bit, but we're just warming up. right? But to show you the general method, I'm gonna use this point, right? We can use either point, XY coordinate, because remember, as long as we know the slope, then all the points on this line, right? Doesn't matter where they are, they're just gonna follow this line. Okay. So we can use, oops, that's not how you spell either. Either point to find the y-intercept, but I will use 3, 9 to illustrate. Like I said, 0, 3 would be kind of cheating. Not cheating. So the equation that we're trying to find, right, is y equals mx plus b. We have m. We found m already is 2, so y equals 2x plus b. Oops, a little lofty there. We're trying to find b. If I know 3, 9 is on this line, can't I just use that 3 as my x and the 9 as my y? Sure can, right? 9 and 3, just temporarily, right? I know those 2 points are on this line. In fact, I'm trying to force them to be on this line, right? So then I get 9 is equal to 2 times 3 plus b. All of a sudden, not too bad solving for b, right? So b is going to be 9 minus 6. Which we already knew, right? Because the b is the y-intercept where it crosses the y-axis where x is 0, right? Going back to the general interpretation of the y-intercept, right? We already knew this. Since 0, 3 is on the line. It's all on the line. Right? But I wanted to show you with a different point because it's not always that obvious. Therefore, y equals 2x plus 3. These divorce. Nice. And then you leave the y and the x open, right, for any values, not just the 2 points. But we only need 2 points in order to find the equation of the line. Okay. Any questions about that one? Just slowly graduating through skills. We found the slope, given different kinds of information, same information, but just in different formats. And then now we're finding the equation of the line, right? And let's see here. Yeah, for anyone printing the examples, I did just smush them all onto one page, just so that you weren't printing pages upon pages of blank work. Okay. Let's do the same thing. So we're going to write linear equations for a line passing through the points -2, 3, and 4, 0. Step 1 is find the slope. And then step 2 is use one of these points. Notice that we don't have the y-intercept anymore. And so use one of these points. It doesn't matter which one, because they both have to be on the line. So whichever one's more convenient is the one I would recommend, right? to find the y-intercept and then write out your line. Let me just remove this. It's more of a note to myself. Okay. Okay. I'll let you try it. I'll write it out in silence and then we'll walk through it. Okay. You know how to find the slope? We know how to find the slope. We've been doing that all morning. I get a slope of -1/2. Everyone's on board? Cool. Step 2, kind of the new part of this, you can use either of the 2 given points to find the y-intercept. I decided to use -2, 3, mostly because it's the harder point, right? But I encourage you to pick the easier point, of course, but I just want you to see that it would be the same, right? Why is 4, 0 easier, quote unquote? Because if x is 4, y is 0, right? 4, and this is set equal to 0. Solving for b then just becomes a little bit easier. But it really doesn't matter. And so I'm going to use -2, 3. So I put in x is -2, y is 3. 2 divided by 2 is going to cancel to 1. And a negative times a negative makes a positive, so I canceled those as well. And so I'm left with 3 is 1 plus b, which means that b is 3 minus 1, so b is 2. So the y-intercept is 2. You could do a quick run through of 4, 0, meaning the y would be 0. Right? 0 is -1/2 times 4, which is -2 plus b. Solving for b, I can add 2 to both sides and I get b equals 2 again. Right? So either way, you would get to the same spot. We'll do this one a little bit quicker. I'm tempted to put it in after, but I think we've got time. But I will add a page. Not because we need a whole page, but it's nice to have space. I have to remind myself that I don't need to be cheap with virtual space. Do I? Okay. There we go. So again, step 1, find the slope. Step 2, find the y-intercept using one of those 2 points. So m, right, not outlining the steps anymore. Right? You don't have to write out the steps. I just find that it's helpful. Okay. M is f of x2 minus f of x1. I do want to see the general formula that you're about to use. Right? That's more of a safeguard for you in case you copied it down wrong or something. But if you follow through with what you said you were going to do, that's worth a lot more than all of a sudden you kind of just got to the answer, right? I don't really care about the answer so much as the process, right? So if you tell me that this is what you're going to do, and then you do that, that's worth more than just all of a sudden switching to the right thing. F of x2 is 7 minus f of x1 is 3 divided by x2 is 4 and x1 is 2. I'm not writing down what x1 and x2 are on purpose, just so you can see kind of the smallest amount of work that you would need to show, right? Four divided by 2. Wow, we're really digging the slope of 2 today, huh? Like every example gives us a slope of 2. So then y is equal to 2x plus b. Neither of these are kind of speaking to me in terms of simplicity. I'll just use the first one. F of 2 is equal to 3. 3 is 2 times 2 plus b. I will do here from f of 2 is equal to 3. When x is 2, y is 3. 3, 2. So then I get 3 minus 4. B is 3 minus 4. This jump here, everyone's usually okay with that when I do that in class, and then you're looking back and you're reading the notes. And I always get, hey, how did you get from this line to here? Right? I kept B on the right-hand side, and I moved the 4 over to the left-hand side, but then I swiveled them around the equal sign, right? So kind of a lot happened from here to here, but everything is above board, right? And so, because I like to have what I'm solving for on the left-hand side. Okay? So take a moment to talk yourself into, okay, yeah, that makes sense. Okay. So then B is -1, therefore y is 2x minus 1. I'd say this is the least amount of work that you could possibly show. I mean, I guess you could skip this step. Wouldn't, but you could go straight to 2. Here, this is the least amount of work you could show for full marks. I know, but I need to be able to follow your. You know what? That makes marking so much easier.
That's what I'm saying. It's a win-win.
I should, because I taught you so well.
Yeah, just assume.
Yeah, I think so. I think, you know what? Yeah, we don't even need to have a test then.
Well, I don't think you need the class, just like assume we'll get 100%.
Yeah, next I'll just bring like Finding Nemo or something, and we can just work through that. Why Finding Nemo? I have no idea. It's the only movie that came to mind.
I watched that like 8 times the last 2 weeks. All the time. Or Wiggles. I've already seen Finding Nemo so many times. What's one? At least there's something I've not watched like a lot. Oh,
Maybe the final exam is just us doing a theatrical version of Finding Nemo.
Yeah.
Everyone has to do their lines. It's water related, and I'm sure there's a math joke in there somewhere. So maybe that's why I thought of Finding Nemo. It's not, but. Okay. Write an equation for the function graphed. So we've got function as a graph. We've got some clues. Now, one thing that I will say is from here, we just need to pull 2 points that we're feeling confident about, right? And so it would be tempting to use the y-intercept, but it's not obvious what that y-intercept is, right? So that's not one of the points that we could use, but there are a couple of points on here that I would say look pretty good. Here, I'm feeling good about this being at 4, 0, right? And I'm feeling good about this being at -2, -2. So now, all of a sudden, I'm back to that very first scenario where I just have 2 points and I need to find the equation of this function. Let's see if I can just give myself a little bit more room. F of x2 minus f of x1 over x2 minus x1. F of x2 is 0 minus f of x1 is -2 divided by x2 is 4 minus -2. So 2 over 6. Not nice. You can reduce it. I'm going to keep it as 2 over 6. Doesn't matter. So if you want to, go ahead. But they're the same number. It's just how you write them. And so I'll make a note here. You can reduce this or leave it as is. I'll leave it as is, just to show you. Okay. Y equals mx plus b, right? Step 2, I want to find that y-intercept. And I have 2 points. And I think dealing with the negatives is kind of annoying. So I'm going to use 4, 0. I always avoid the negatives if I can, but give myself a little bit more room here. Using 4, 0, y is 0. The slope is 2 over 6. Whoops, 2 over 6 times 4. Plus b. Because I'm multiplying and then dividing, it doesn't matter what order I do that in, so it's going to be 8 over 6. Buckle up. B is going to be -8 over 6. That's a leap, sort of. Why is it negative? So I had to subtract it. So how I do it is I keep b positive and I move this 8 over 6 over to the left-hand side by subtracting it. So 0 minus 8 over 6. And then b is -8 over 6. So therefore, y equals 2 over 6 times x minus 8 over 6. I'm fine with the answer in that format, right? It's not reduced or anything, but our calculator just does it, so there's no point in making it do it. You can if you want. Fractions. Oof. Okay. I'm gonna move this down here. Word problems. Tricky, tricky. Or any questions about that one before I just keep going? At age 20, the maximum target heart rate when exercising is 170 beats per minute. At age 70, the max target heart rate is 128 beats per minute. If the target heart rate decreases linearly with age, write an equation relating them. Okay? So if it's a decreasing with age, that tells me that age has to be the X variable, right? Because it's decreasing with age. And so as you change age, right? Therefore, X is age, right? Is what that tells me. Which tells me that f of x1 we're given at age 20, then the target heart rate, so let's see here. I'll do h of age, h of a, heart rate at age. Which means that we're given h of 20 is 170, and we're given h of 70 is 128. So we're given 2 points, which is all we need. So first thing we need to do is find the slope, right? We want to write an equation relating them, which is a linear equation because it decreases linearly. Decreases is a clue, right? That means we have to have a negative slope, right? So m is f of x2 minus, oops, that doesn't look like a 2, minus f of x1. It's 2 minus x1. F of x2 is 128, f of x1 is 170, and 70 minus 20. You know, add a page here. 128 minus 170, negative 42, divided by should we reduce this one or just leave it? Leave it. Or negative 21 over 25. I didn't do that in my head. I just let the calculator do it. But I should have played it off as if I did, I guess. It's not terribly impressive though. We got the slope. Need to find the intercept. Y equals mx plus b. And either one of these points will work. We can use the first point when x is 20. The output is 170. $170 is, I'll keep the non-reduced one. Negative 42 over 50 times 20 plus b. Okay, a little bit more work this time, right? So we'll kind of walk through it here. Negative 42 times 20, let's do that first. Negative 42 times 20 puts us at 170 is at negative 840 over 50, which I'm going to see if it reduces to anything nice. It does not, so I'm just going to leave it as is. So now solving for B, and I'm going to subtract this, or sorry, add that to both sides. So 170 plus 840 divided by 50 is equal to B. I'm going to stack my equal signs as much as I can. Okay. If it's negative, I have to add it to both sides. Which means if I do this revolving door, what do I need to do with my fractions? In order to add or subtract fractions, I need to have a common denominator. Right? So here, in order to add or subtract fractions, we need a common denominator. Now, there are lots of fancy ways that you've probably learned to find a common denominator, right? I'm gonna go with the clunkiest way, which is my preferred way, just because it'll always work and you don't need to put any thought into it, okay? And so here's what this is gonna look like. Now, what I'm gonna do is I'm just gonna rewrite this on a swivel, put the B on the left-hand side, and then I'll have more room on the right-hand side to do my work. So let's do that first. B is 170 plus 840 divided by 50. Technically, 170 is divided by 1. Right? Adding two fractions, one's just nice and easy. The other one, not so much. So to force a common denominator, I'm going to force the common denominator to be the first denominator times the second denominator. How am I going to do that? I'm going to multiply the second term by 1 over 1, right? 1 divided by 1 is 1. I'm allowed to multiply by 1. It doesn't change anything, right? But this first term, I'm going to multiply by 50 over 50, right? Another trick, 50 over 50 is 1, right? But when I'm multiplying fractions, I multiply across, okay? So what this is going to look like is that B is 170 times 50 over 50. Talk yourself into, okay, 50 divided by 50 is 1. I can always multiply by 1 and it doesn't change anything, right? And I guess technically 170 divided by 1. Let's do that just to show that there's still fractions. Plus 840 divided by 50 times 1 over 1. Right? Taking this one and used it over itself over here. It didn't do anything, but neither did this 50, right? Kind of made a mess. Gonna get some big numbers, which is why it's good to reduce them, but we don't have to because we have calculators. Okay? But multiplying by 1 and multiplying by 1 doesn't change any of these values. So then what does this look like? This is gonna be 170 times 50 is 8,500, because if I'm multiplying fractions across, right, then I can just multiply this and multiply this. Right? Divided by 1 times 50, plus 840 over 50. So now I've forced this common denominator of technically 1 times 50. Right? We have now forced a common denominator of 1 times 50, technically. But I didn't even write the 1. Now that I have a common denominator, I can add the tops and put it over the tops, the numerators, and put them over that common denominator, right? And so I can rewrite this as 8,500 plus 840 divided by 50. Right? It gets put over that common denominator that we've forced. Uh, 8,500 plus 840, I get 9340 divided by 50, which probably does reduce, but not very much. Just 934 divided by 5, but I'm just going to leave it as is, for simplicity's sake. So then therefore, y is, the slope was negative 42 over 50 times x plus 9340 divided by 50.
Is it okay if I just put 186.8 instead of 9340 or 50?
As long as you're not rounding anything,
No.
if it's a, if it's, if it keeps going past 9 decimal places, it's pretty safe to say that it
Oh, okay, it's just 1 decimal.
yes, but if it's only showing 1 decimal, that's totally fine. Yeah, then you can just use the decimal version. But I want, because we're solving for the intercept using the slope, then I want to have exact values. Nice. But yeah, if it just gives you like 1 or 2 decimal places, totally safe. Nice. Little refresher on adding and subtracting fractions too. That never hurts. How about another word problem? Or what was this? What were we doing ages ago? Oh, the heart rate. We got a negative slope. That's good. And this was not a simple linear equation, right? Fractions and things. But we did it. You could even rewrite this. We introduced h of a is negative 42 over 50 times a plus 9340 divided by 50. If you wanted to use the h of a and a. Water boils at 212 degrees Fahrenheit, which is 100 degrees Celsius, and water freezes at 32 degrees Fahrenheit or 0 degrees Celsius. We want to find the conversion equation between Fahrenheit and Celsius. Okay. So we've already seen this conversion equation, but how do we get there? Right? So now I have an input and I have an output. In fact, I can kind of use whichever one I want. But let's say 0.1 is going to be at 212 and 100 Celsius. Should we use the Celsius as the input and the Fahrenheit as the output? Doesn't matter, right? But what am I doing? Oh, that's nice. Input, output. Let's see here. Let degrees Celsius be the input and degrees Fahrenheit be the output. So then we have something like F is M times C plus B that we're trying to find. You can try it using the opposite input output, but it's just rearranging the formula. So then we're given when the input is 100, we get an output of 212. When the input is 0, we get an output of 32. In terms of our x1, x2, right? Our x1 is always the smaller value and our x2 is always the larger value. So even though they're given in kind of the wrong order, this is going to be our x2 and this is our x1. It doesn't really matter, right? As long as you are consistent, but I want you to adopt the that thinking. So here, let this be x1, f of x1, and let this be x2, f of x2, just for some consistency. Just because 0 comes before 100. You can try it reversing those x1 and x2s, but we would get the same thing, just kind of negatives would move around. Okay. First thing, because find the conversion equation is going to be a linear equation. And so really all we're doing is finding the same thing that we did before. We want to find the slope. F of x2, oops, f of x2 minus f of x1 divided by x2 minus x1. We decided f of x2 is 212 minus f of x1 is 32 divided by 100 minus 0. 212 minus 32 is 180 divided by 100. Or 1.8. Because it rounds out to a nice clean decimal, like we were saying, you're allowed to use it. I'm going to keep the fractions just so we can work with some more fractions. Okay, but you could use the 1.8 safely here. Okay. So then I'm trying to find F is m times c plus b. And we found that 180 over 100 is my slope plus b. And f. Let's see if there's an easy point. They're both pretty easy, but in the second point, I let c be 0, right? Which means I don't need to deal with the fractions, right? So that would be the point I would choose. But because we're doing math, why not do the harder point? Why not? I will use 100 to 12 because 0.32 is too easy. It's the one I would choose if I was you on a test, of course. But in this case, the Fahrenheit is 212. 180 divided by 100 times 100. It's not too bad. 100 divided by 100 goes away. B becomes 212 minus 180. I have a guess.
That might just reduce that to 9/5. What it is.
Yeah. It would have worked, right? Because if you have 100 divided by 5, it would still work out, but this way I got to cancel it. So then that equation would be degrees Fahrenheit, or let's just call it F. F is 180 divided by 100. Oops. Times the Celsius plus 32. Or 1.8. Which section was it where they told us what the formula was and we worked around, inverse functions. They used 5/9 times the Fahrenheit minus 32. But that's for the Celsius. Where are we? There. So in this equation, right, we could rearrange this and solve for C and find that it becomes what was in that example, right? Can rearrange things. They've reduced it, right, to 9/5, but I'll make a note here. Because, right, 180 divided by 100, yeah, or 9/5. Okay. Nice. Any questions about that one? Oof. You ready to go to the next section? I feel like we've already worked with graphs of linear functions, but we'll do some more. Okay. Just a couple of properties that we need to have a good handle on. Okay. And so if we have a y equals mx plus b, or f of x is b plus mx, right? It's your job to recognize that this is just a straight line, right? There's just one input of x, a slope and an intercept and an output, right? That makes it a straight line. We know already that b is the vertical intercept, so the y-intercept of the graph, right? And it tells us we can quote unquote start our graph at 0b, right? Lines keep going forever. But m is the slope of the line, right? Tells us how to get to the next point. Once we have at least 2 points, as we've seen, all we've needed are 2 points on this line. Then what we can do is we can find the equation of this line and we can draw it. Right? Just need 2 points and then you connect them and extend the line. Now let's see here. Oh, okay. Match the equations with the graphs. I think I deleted too much here. Yikes. I did. There are no equations. I deleted them. We can. How about this? Bad, Emily.
Okay, I got A. B. Oh,
We ca-
actually, no, these are.
We
very
can do,
easy.
yeah, we can do it, but man, that's a lot. Yeah, everyone pick a favorite and I'll add it to the notes before I post them. But I think you get the idea, right? You can find the y-intercept of each of them, right? And then you can find another point to find the slope.
They're not that diff- if you actually
Yeah,
look at
which
it,
way-
they're
Oh,
not
yeah,
that
we
difficult.
just use our, like what we learned about classes down.
Yeah,
Right.
like,
Yeah, I like
I've
these.
got
Yeah.
all the equations.
These guys
I'm
are real
pretty
nice.
sure I could write any
These
of the
cool.
And
equations.
it's like separated from the rest.
Yeah.
I like.
Yeah, because.
Bad, Emily, bad.
A's
I'll add it to the notes and I'll add it. But I feel like we're feeling pretty confident anyways, it sounds like, so that's awesome. It's not bad. Because you can see the y-intercept of all of these, right?
Exactly. So it's.
You've got your first point already.
-2.
You just need to find the slope. So you know how to do that. That's boring.
Exactly.
Boring. What about the horizontal intercept? So we've talked about the y-intercept, but the horizontal intercept is the x-intercept. The lesser known intercept, or the lesser cared about intercept, right? It's not part of our equation, but sometimes it's nice to have to know where it crosses the horizontal axis as well, right? Crosses the x-axis. By reverse definition, if the y-intercept is where x is 0, the x-intercept is where y is 0, right? So here, I'll give myself a little bit more room. I have y and x here, then the x-intercept is where y is equal to 0, right? Or more properly, where f of x is equal to 0. Right? So now it's the value of x where y is 0. Right? Whereas the y-intercept is the value of y when x is 0. And maybe I'll add that. The value of x, and I'll change this to when y is 0. Yeah. So you can use the same technique, right? Just force y to be 0 instead of forcing x to be 0, and you can solve for the x. Horizontal and vertical lines. Horizontal lines have f of x is equal to b. So a horizontal line, I'm gonna just give myself one line here, a little tight. A horizontal line looks like this, right? I always have to kind of talk myself through it, right? But the horizon goes like this. So if you think about the horizon, then it's straight across, and then horizontal is straight across, right? And so here, this is f of x is equal to b. What does that mean? I can put in any value of x, and it would just put me at b, right? Whatever this point b is. Right. So all the outputs are b regardless of what x is. Now a vertical line looks like this. If I'm at A here, then a vertical has to be the opposite of a horizontal. maybe you're just good at remembering these things, but I'm not. So x equals a all the time. And the output is going to change, sure, but x is always a. Right? Is that a function? No, right? The vertical line test, I get all possible values of y for the same input of x. So we wouldn't know where to map it to, right? So it's not a function, but that's okay. It's just a vertical line. Okay. Okay. What if we want to find the horizontal intercept of f of x is 3x plus 1? The horizontal intercept is where f of x is equal to 0, right? And I want to solve for the x that makes that happen. So what can I do? I can force f of x to be 0. 0 is 3x plus 1. Solve for x. Fair enough. I get -1 is 3x, which means that x is -1 over 3. Again, doing some sneaky maneuvers, but I think we're getting used to it. Maybe. Right? Sneaky maneuver number 1. Just subtract 1 from both sides. Don't even do 0 minus 1, just go for it. Then I'm left with 3x on the right-hand side, which then, if I'm trying to solve for x, I divide both sides by 3 over here, but then I want to solve for x, so then I do a little revolving door here. Okay. So the horizontal intercept of that line is when x is -1 over 3, and the y output there has to be 0 because we forced it to be 0. So, or -1 over 3, 0. Knowing this format, right, f of x equals 3, is a horizontal line, right? And x equals 3 is a vertical line. So let's just have a look and see what those look like. I'll use 2 different colors. If no matter what x is, the output is 3, then I'm here. And what's that going to look like? Just keeps going and going and going and going. Doesn't matter, or it doesn't care rather what x is, it'll always return 3. Whereas x equals 3, okay, so here I am at 3, 0, but it doesn't matter what the value of y is, it'll always just be at x equals 3. I'll just extend it. And I'll use little arrows to indicate that it keeps going and going and going and going. Nice. We don't talk about vertical lines because they're not functions, but what's the slope of a horizontal line? Good. Because the rise is 0. rise over run, doesn't matter how much. If you're rising 0, then your slope is 0. So notice m is 0. If I tell you 2 lines are parallel, you probably imagine 2 parallel lines like this, right? Running in parallel. That's kind of terminology that we use just in everyday language. Okay. But what does it mean in terms of the slopes? It means the slopes have to be equal to each other, right? And so 2 lines are parallel if the slopes are equal, okay? Or if both lines are vertical, then okay, fine, but that's kind of boring. So what this means is that if I have an equation, f of x is b1 plus m1x, and g of x, or plus, yeah, and then g of x is b2. I put these little subscripts on here because if they're just b, what does that mean? It means that the intercept would have to be the same for both, and that's not necessarily the case, right? And so I put a little b1, b2 on there, but b2 plus m2 times x, then the lines are parallel if m1 is equal to m2, right? How can you reverse this, right? Or how could we kind of make a bigger problem out of this? Well, what if I tell you, okay, find the linear equation of this line, right, or this relationship. We know how to do that. That's what we did all morning. So you find the first equation, and then what do? Well, a follow-up could be now find an equation of a line that's parallel to that line passing through this point, right? And I'm confident I have examples, I guess. But maybe not yet. Let me see here. Do I? Sorry, let me just scoot ahead here just to see if I have. There it is. Okay. Then I'm not worried. Just worried. No, I wasn't. Okay, so what was I gonna put here? We can force 2 lines to be parallel by forcing them to have the same slope. So we need to have a good handle on, okay, if I say parallel, then they have the same slope, right? M1 is equal to M2. And I've got the example way down, so we'll hold off. So that's easy enough, right? If you're drawing lines like this, we've got f of x is b1 plus m1x, and a parallel line. Let's see if I can pull that off. Okay. It's not very good because it's hard. Or let's call it g of x is b2 plus m2 times x. Those are parallel. A little bit juicier are perpendicular lines, right? So now I have 2 lines f of x and g of x, both just straight lines, right? Linear equations. The lines are perpendicular, or maybe I won't highlight that part because we really only need this part. If m1 times m2 is equal to -1. So let's see here, what does a perpendicular line look like? Well, I might have something like this. F of x is b1 plus m1x. And perpendicular might look something like this. G of x is b2 plus m2x. If I toss down a little right angle here, that means 90 degrees, right? And so this is a 90-degree angle. That's what it means to be perpendicular. Even though I didn't draw them quite perpendicular, but then I'm saying, hey, they are. There's 90 degrees there. So if they're perpendicular, if you take the m1 times m2, so if you multiply the slopes, right, then you have to get to -1, which means that if, or I guess since m1 times m2 is -1, that'll more obvious too, then if you're solving for the second slope, m2 must be -1 divided by m1, right? Which is usually how we end up using this formula, right? But I do find that this is a little bit easier. If I multiply the two, I have to get to -1, but really, how's this gonna work, right? Find the equation of the first line, let's say this green line, and then find the equation of a line that's perpendicular to this point, right? Which means you have to find the slope using the first line. M2 is -1 over M1 of the first slope that you found, right? And instead of doing that, I'm gonna grab this. Hopefully I can just grab it and do that here. So here, if I have some slopes, some first slopes, then my second slope, if it's parallel, that's easy enough. They have to be the same by definition of having parallel slopes. So then here, M2 must be 2, right? And I'm doing parallel here and perpendicular here. Kind of a weird grid setup here. But M2 must be 1/2. Oops. They're just the same, right? By being parallel. They have to have the same slope. Possibly different intercepts, right? Or likely different intercepts. Technically, the line on top of itself is they are parallel, but boring. This one though, if I want to find the slope M2 that's perpendicular to a slope of 2, right? A slope of 2 looks like something like this, right? Positive, kind of upward incline. So then I'm expecting a negative slope running the other way, right? I'll remove this, but maybe. So what am I going to do here? For each of these, you could just have M1, which you're given, times M2 is equal to -1, and then just solve for M2 each time. That's why I think this is the only one that you need. But because we are looking down the barrel of doing it 4 times, right, you can solve for M2 and then just use that formula instead. Okay? And so here, this is going to look like M2 is -1 over M1. In this case, I am going to go straight across, which means M2 is -1 over 2. So the perpendicular slope would be -1 over 2, which makes sense if we imagine lines like this. How about the second one? M2 is -1 over M1. -1 over 1 over 2 is a fraction over a fraction, right? And so -1 over 1, technically, because I can see that I'm about to work with fractions. Fraction over a fraction, I need to flip the denominator and multiply. So this is -1 over 1 times 2 over 1. Then I get -2 divided by 1, putting me at -2. Looking at these relationships of the first and the second set of lines, right, I could be convinced if the original slope was +2, then the perpendicular slope is -1/2. If the first slope was 1/2, second slope is -2. Right? It's kind of similar relationships there. What if we have a slope of -1 over 3? M2 is -1 over -1 over 3, which is -1 over 1 times -3 over 1, which is -1 times -3, which is 3 divided by 1. Last one. M2 is -1 over 3 over 4. -1 over 1 times 4 over 3, I get -4 over 3. Okay. We'll pick up there, but I'll bump this up for next day. Do you have any questions? Let me know. Otherwise, see you on Thursday because I am out of time. Oops.